Hello everybody. In this video I will give you a quick tutorial how to build such a high voltage impulse generator that I have shown you in my previous videos. And to start off I will show you the schematics of the setup again. So we basically have one bifilar coil, a MOSFET or the transistor, and a signal generator. And the signal generator gives the MOSFET a square wave signal that tells the MOSFET when it has to switch the DC voltage that is applied on and off. And this is basically how it works. Very easy. And now I will show you how to actually build this. And to start off, I will show you how I built such a bifilar coil that you can see here. It's actually very simple to make, and for this I used some speaker wire. This is just two wires together, like you can see here. This is pure copper, so make sure your cable is pure copper and not copper clad aluminium or copper clad steel, because especially with copper clad steel wires you have different characteristics, so just make sure it's pure copper. And also the diameter or gauge of the wire is not that important. This is 0.75 square millimeters in diameter, the cable, but you can use different thickness of wire. So to build such a coil, you just take this speaker wire and you leave yourself some slack right here, and then you basically make your first turn like this. And it's easier if you do it on a flat surface, so yeah, you will get a really nice and flat coil. And after you have made the first turn, you just continue to wrap the cable around here and make more and more turns. Like here, I'm just doing this very roughly so you can get an idea of how it's done. You can always tighten it up again, and make sure that you always hold the cable at one end so it doesn't come loose. And yeah, like you can see here, I have already made 3 turns, and it is important that you always make sure that it's wound very tightly, that there are no gaps between. And what I did is, after a few turns, like 5 or 6 turns, depending on how tight you can wind it and still hold it, I just glued it with some hot glue so that it is fixed. And then it's way easier to continue with more and more turns, and it won't come loose again. Yeah, this is basically how you make a bifilar coil like this, and I think this is by far the easiest way to make a simple and very well functioning bifilar coil. And yeah, like this. You can also, if you don't have these 2-wire speaker cables and just a single copper cable, you can of course make the bifilar coil in different variations, like I made it here. This was my first coil I've made. Yeah, it's not really perfectly made, as you can see, but it doesn't really matter, it works just fine. So I have made this with just single wire. As you can see here, I had 2 single wires and made them flat. So this is only 1 layer and not 2 layers of wire like here. So shape and geometry of the bifilar coil doesn't really matter. I've also made bifilar coils like this. This is a rod-in coil, completely different geometry, but it's also bifilar wound and connected, so the geometry is not that important. It is just, this is the easiest to build and it works quite well. And yeah, after you have finished it, wounding your preferred diameter, this is I think 19 centimeters in diameter, but it's not that this would be crucial. And after you have finished it, you have connections coming from the inner rim. You have 2 wires coming out, and from the outer rim also 2 wires coming out. And what you basically do is, from the inner rim you take one cable and connect it to the opposite cable of the outer rim. So for example, I've taken the black wire from the inner rim and connected it to the red wire coming from the outer rim. And these leaves us with 2 connections that are open. Here the red wire from the outer rim and the black wire from the inner rim. And the black wire from the outer rim is connected to my MOSFET that is shown here. This is just a MOSFET attached to a heatsink. It's actually not needed, the heatsink, because it doesn't get hot, but yeah, I've just done this for safety. You don't need a heatsink for this setup. And yeah, the outer rim of the bifilar coil gets connected to the drain of the MOSFET. This is the only connection between the bifilar coil and the MOSFET. And what you can see here, the inner rim positive connection from the bifilar coil is connected directly to the DC voltage plus, and the DC voltage minus is connected to the source of the MOSFET. I will show you again if I find it. Where have I put it? Here. As you can see here, I've connected the outer rim to the drain and the inner rim to the positive, and the negative of my DC is connected to the source of the MOSFET. So let me continue with the MOSFET itself. A MOSFET, as you maybe know, is just a high power transistor, and for this setup you can use different kinds of transistors or MOSFETs, and it's only important that they're N-channel, or for transistors they are called NPN transistors. Actually a lot of transistors that you can find in old electronic devices where you can scrap them from, or if you want to buy a new one, they are very cheap. Just make sure it's an N-channel or NPN type transistor that we use here. And also what I've done here is I've connected to the gate of my MOSFET a small resistor. This is just to protect the gate of the MOSFET. And yeah, now we come to the switching part of the MOSFET. It is switched via a signal generator. So the MOSFET is basically acting as an electric switch that just switches the DC voltage on and off. And this does this very often per 1 second. Like in my setup, around 30 to 40,000 times a second. So for the MOSFET that you use, you have to be careful that you use a MOSFET that can switch very fast. I can only recommend you the MOSFETs I used. These are basically high frequency fast switching MOSFETs, and for this I've used an IRFP 460A MOSFET. and you can use different ones. I've also used different ones, they also work too. But the characteristics of the MOSFETs are quite important, meaning the switching time of the MOSFET, because how fast the MOSFET can switch will also determine the frequencies you can use and how high the voltage impulses are. But just try with whatever you've got and you will see the results. From my experience, almost all of them will work just fine. And for my setup, I use an oscilloscope for one to show the signal, and I also use this as a signal generator, and the signal generator of this oscilloscope is very weak. It can only put out 2 volts peak to peak at a very low current, and this is just not enough for a MOSFET to switch. So I have to amplify the square wave signal that comes from my oscilloscope or signal generator with a small audio amplifier. And this is what this device here is. This is a cheap audio amplifier I've bought off Amazon, and yeah, it works perfectly fine for my purpose. And basically what I do here is I have plus and minus from the speaker output, and I connect the minus to the source of the MOSFET, which is also my ground point, and the plus to the gate. And before the gate I have this resistor just to protect the gate a bit. Yeah, and this is basically the whole setup. As you can see, you only need a bifilar coil, a transistor, and a signal generator, and of course a power supply for the DC voltage. And that is all you need to build such a high voltage impulse generator. This is the simplest version I could come up with. And now I will also power it on and show you a bit how it works and how to operate it. And also what I did not explain so far is this big capacitor. You actually don't need it. This is just for protection of my power supply against voltage spikes, but normally most power supplies are not, they can handle these spikes. This is just a protection. You can also use a way smaller capacitor to protect your power supply, but as I said, you don't really need it. And yeah, so first off, I will turn off the oscilloscope, which also acts as the function generator, as you can see here. And I will tune the frequency to around 37.5 kilohertz. That is just a frequency I have seen that works good for my setup. And for the next step, I will turn on the audio amplifier that amplifies the signal that is coming from the signal generator. And as you can see, right now not much is happening on the oscilloscope, because I have to first turn on the DC power supply, and this is what I'm doing right now. So I will slowly raise the voltage to around 12 volts, and you can also see on the oscilloscope we are picking up a signal from this probe that is actually not connected so far, and this is just what it picks up wirelessly. And now I will just connect the probe to certain points of my circuitry so you can get a better idea of what is going on. So if I just connect one end on the ground point or source of the MOSFET, you can see this sine wave, and this is just transverse electromagnetic waves that are generated, they have a peak-to-peak voltage of 1 kilovolt. So the output of this audio amplifier is 26 volts peak-to-peak, but the coil and the setup itself amplifies it to around 1 kilovolt peak-to-peak. But this is not what we're actually trying to achieve, this is just a byproduct of it. If I connect my minus of the probe to the source of the MOSFET, as you can see here, you see these extremely high voltage spikes that are just shooting way above what the oscilloscope can show. And this is a 1:100 probe, and we have 500 volts per division, so the maximum that can be shown here is 4 kilovolts. And we are generating voltage spikes that are way higher than 4 kilovolts. So actually with my oscilloscope I can't even measure how high the voltage spikes that we generate actually are. And this is also the reason why I always leave the probe unconnected, just laying right next to it. So I will see the form and shape of the signal anyway, but the voltage that is indicated is of course not the real voltage. And yeah, if you want to do some testings with the setup, because right now you can't really see or feel really anything from it, and you would think, what is the use case of this? And this is basically creating a strong electrostatic or static electric field, or also called dielectric field, meaning that we have really high voltage but with almost zero current behind it. As you can see here, the power draw from, or the amp that are drawn from the power supply are almost zero. And as you can see here, I have a LED ring with just 34 1-watt LEDs connected to a copper coil with 3 turns. And if I put it on here, it will be influenced by this strong electrostatic field or dielectric field, and it will induce voltage and also current into the coil, and this will light up my LEDs quite bright. And as you can also see, the power draw is not very high from this. And now comes the part, how do you figure out what is the resonance frequency for my system? And this is actually quite easy to do. So what I'm going to do now is I will connect my probe directly to the LEDs, because there the voltage is not that high and I can still show it on the oscilloscope like this. And now I switch to my function generator, and basically to determine the resonance frequency of your system, it is quite easy. You just adjust your frequency and look for where the voltage is the highest. As you can see, if I turn it down, maybe, yeah, I don't know if you can see it on the camera so well, I will zoom in a bit. Like this. Yeah, it won't get sharper, but you will see what I mean. And if I go lower, it will completely stop to pick up anything because it's not in resonance anymore. If I go higher, the voltage spikes will also get higher. And you can see here the voltage. And depending on how high I go on the frequency, the voltage will also go higher. Now we are at the point where the frequency gets higher but the voltage drops again, so I know we are already past the resonant frequency, and you just adjust your frequency to a value where your voltage spikes are the highest. And this is, the easiest way to find out the resonance frequency of your system. So you don't need to do any complicated calculations or something like this. Simply adjust the frequency and look for where the voltage is the highest. And if you don't have an oscilloscope, it also doesn't really matter. If you have an LED ring set up or just connect some LED or lamp to it, you can also simply just adjust your frequency of the function generator you have, and you will see the LEDs will get dimmer if I tune it out of resonance. And you simply look where the LEDs or the lamp is the brightest. If I use higher frequencies, you will see it will get dimmer until the lights go out. So you don't have to measure the coil itself and calculate the resonance frequency. It is the easiest to just test it by adjusting the frequency to a value where you get the highest spikes. And this is basically the simplest form of such a high voltage impulse generator. Very easy to rebuild, and if you use it in a setup like I've used it here, it is also safe. So all the voltage is very high that we are using, but there is almost no current behind it, and the human body can withstand high voltages pretty well, so it doesn't matter where I touch it. Maybe we'll dim it because I ground the voltage, but you will barely feel anything or almost nothing, no matter where you touch it. So this is a simple and easy way to experiment with high voltages, with low current. And I hope I explained everything quite well. If I forgot something or you have questions, you can of course ask. And that's it for now. So thanks for watching and goodbye.